Hello, and welcome to 12.6 surface area of volumes and spheres, and volume of spheres. A sphere, we're going to define this really quickly. Let's draw a circle right underneath that definition, and we're going to draw kind of like a partial circle around this, a dotted line right around, and we have a three-dimensional object. Now, a sphere, like I just said, is a 3D shape, which each point on the surface is equidistant to its center. So that means, let's grab a red, let's draw the center of our sphere, and no matter where you land on the actual surface, for instance, if we say that this is 5 meters, it is 5 meters, that is the radius, and it is 5 meters no matter where you go onto the surface of this object, okay? Whether it's along the equator, like in the world, or whether it's on North Pole, South Pole, etc., okay? So, that is a sphere. Now, the surface area of a sphere is more so just a straight equation. How do you calculate all of the surface of a sphere? Well, that would be like if I was planet Earth, we would calculate all of the land mass and all of the water, assuming that everything is flat. Okay, or like a ball, like a tennis ball. You'd calculate all of the fuzzy stuff with all the little white, I guess, stitching or what glues that together. So the surface area of a sphere follows this equation. It is surface area is equal to 4 times pi times radius squared. Okay. Volume of a sphere. Well, let's actually do this real quick. Let's use this as an example. So we're going to do example 1, where as shown to the left. So we're going to use that as an example. We're going to use surface area is then equal to 4 times pi times 5 squared, because the radius is 5. 5 squared is 25, so we get 25 times 4 pi, which then equals 100 pi meters squared. Remember, this is area, so we're still in units squared. Okay? Now, let's talk about volume. Well, actually, let's do this. What happens if something is a hemisphere? Actually, no, we'll save that for a little bit later, because we're going to do volume of a hemisphere versus surface area of a hemisphere and what changes. So let's talk about volume. Volume of a sphere has its own straightforward equation, and that is 4/3 pi r cubed. And that's because we're in 3 dimensions. We have north, south, east, west, and then we have depth, okay? So 4/3 pi r cubed. We're not gonna get into the nitty gritty, how did they solve for this? Just take this for what it is, and we could solve for the actual volume in terms of all of everything that's inside of this sphere. So it would be underneath the crust, all that fun stuff in the earth. I forget all the layers. But using this as an example 2, same as above, we could actually calculate this area. So the radius here is 5 meters, once again. So all we have to do is plug this into our equation. Volume, that area, volume is equal to 4/3 pi r, in this case r is 5, squared. We know, not squared, cubed. We know 5 5 cubed is 125. So bring everything else down. 4/3 pi 125 cubed, or 125. Now, 3 does not, unfortunately does not go into 125. So in order to simplify this, we are going to multiply these two together. And we should get volume is equal to 500 over 3 pi meters cubed. And that's as far as we would go if we wanted the exact answer. Okay, so volume is a straightforward equation. Same goes for surface area. But hemispheres is where it gets weird, where it gets interesting. So we're going to talk about hemispheres. Hemisphere is pretty much half of a sphere. Now, what happens with half of a sphere? Well, let's try to draw one. We draw half of a circle. We draw pretty much the equator of it. And we draw around the backside. Now, surface area actually changes dramatically because if you consider surface area, it's actual, area or surfaces that you can touch. And when you cut a hemisphere, you actually can touch the bottom part of this now, the base. There is an actual base to this. So let's still give a radius. So let's say this radius here, this time around is 6. Let's say inches, okay? Well, we could still calculate the entire surface area, but we only have half of a hemisphere. So logically, we need to consider this. Since we're working with half of a hemisphere, we're going to take that equation, half of a hemisphere, so the sphere is 4 pi r squared, but we're taking half of it. But we need to remember that we are adding on the base. So we're going to add on the bottom part to it. And since we know that this is a circle base, we could add on a pi r squared. Okay? So here's your half sphere plus the circular base, because this has become surface area. So let's do it. Now, we could technically combine some like terms. If we multiply this in, 1/2 of 4 is 2, so this becomes 2 pi r squared plus pi r squared. And if you notice, these are written in the exact same form. They both have pi r squared in it, except one is 2, one of them is 1. So we end up getting 3 pi r squared. Okay? We know the radius here is 6, so we could say 3 pi 6 squared, which is 36. 3 pi times 36. 3 times 36 is 108. So we would get the entire surface area being equal to 108 pi inches squared. Okay, so that's the surface area. Volume, fortunately for us, is actually a lot easier. So I'm going to try to squeeze this in here on the side just so we don't use up another piece of paper. Volume is more straightforward because all we have to do is cut the volume in half. So in this particular case, it's still 4/3 pi r cubed, where radius is equal to 6, and we plug this in. Volume is equal to 4/3 pi times 6 cubed. 6 cubed is 108. We have 4/3 here, and 3 does go into 108 36 times. So funny how this kind of happens. We get a 36 here, and we end up multiplying that with the 4. So 4 times 36, I need a little bit of help on that one. 144, so we end up with a volume of 144 pi inches cubed. Remember, this is volume, so we are in 3 dimensions. Surface area, we are in 2 dimensions, so it is inches squared. So just be mindful, especially for hemispheres, that we add on that added surface area, the base. Okay? And that does it. If you have any questions, please let me know, and I'll see you in the next one. Bye.